Now we're going to take a look at how to evaluate using our sum and difference formulas. So where we begin is figuring out what two unit circle values will give us, in this case, 195 degrees. And we'll think about adding and subtracting various unit circle values to come up with the angle that we need. So since I already know what's going on here, 195 degrees is equal to 225 degrees in the third quadrant minus 30 degrees. Since those are two exact unit circle values, we can use this relationship and our sum and difference formulas to evaluate the sine, cosine, and tangent of 195 exactly. So we're going to start with our sine function. And we've got sine of 225 degrees minus 30 degrees. So we're going to use that second formula on our sheet here, and we'll find the sine times the cosine minus cosine times sine. So we've got sine of 225 degrees times cosine of 30 degrees minus cosine of 225 degrees times sine of 30 degrees. Once we have it set up with our exact unit circle values, we simply evaluate each of those and multiply our answers together. So sine of 225, that's a multiple of 45 degrees, so it's root 2 over 2, but we're in the third quadrant, so it's negative. Sine and cosine are both negative in the third quadrant. Cosine of 30 degrees. Cosine goes backwards, so this is square root of 3 over 2, and we're in the first quadrant, so it's positive. Cosine of 225, a multiple of 45 degrees. Sine and cosine are equal at 45 degrees, and cosine is also negative in the third quadrant, so we get negative root 2 over 2. And finally, sine of 30 degrees. Sine is the one that goes in order 1, 2, 3, so sine of 30 degrees is 1/2. Multiplying our answers together, we get negative square root of 6 over 4, plus, because of that minus a negative, I'm going to go ahead and cancel those. And then multiplying, we get root 2 over 4. So we can simplify this slightly as square root of 2 minus square root of 6 all over 4. And I just switched them around so I could use subtraction instead of two signs with the negative and the plus sign. So there's our sine value. Lucky for us, our cosine is actually going to be very similar because we've got the same unit circle values. We're just multiplying them in a different order. So this is cosine of 225 minus 30 degrees. So we're going to set this up using our fourth formula here as cosine times cosine minus sine times sine. So we have cosine of 225 degrees times cosine of 30 degrees plus sine of 225 degrees times sine of 30 degrees. So filling in these values quickly, we already found all of these values for sine. We're just going to be multiplying them in a different order. So cosine of 225 is negative root 2 over 2. Cosine of 30 is root 3 over 2, plus sine of 225 is negative root 2 over 2, and sine of 30 is 1/2. So comparing this to what we had in the first one, it's actually exactly the same except we're adding instead of subtracting. So I'm going to simplify this fairly quickly. We've got negative root 6 over 4, this time plus negative root 2 over 4. So when we combine these, we have negative root 6 minus root 2 all over 4. And finally, let's take a look at tangent. So we have tangent of 225 degrees minus 30 degrees. So this will be the last formula on our sheet. So we will have tangent of 225 degrees minus tangent of 30 degrees all over 1 plus tangent of 225 degrees times tangent of 30 degrees. So let's see what happens when we start to evaluate this one. Tangent of 225 being a multiple of 45 degrees, tangent is 1. And in the third quadrant, tangent is positive because sine and cosine are both negative. Tangent of 30 degrees, again, if you don't have this memorized, you can generate it doing sine over cosine, but it is helpful to have it memorized. Tangent is root 3 over 3 at 30 degrees, or pi over 6, and tangent is square root of 3 at 60 degrees, or pi over 3. All over 1 plus, and again, tangent of 225 is 1, so we don't really need to write that when we're multiplying, times root 3 over 3. Now we need to simplify because we have complex fractions. We've got fractions within fractions. So in the numerator, I'm going to rewrite my 1 as 3 over 3 so that I can subtract my fractions. So there's my numerator, 3 over 3 minus root 3 over 3. And then in the denominator, again, I'm going to change my 1 to 3 over 3, but this time I'm going to add it to root 3 over 3. And then to simplify my complex fraction, I'm going to multiply by the reciprocal. So we have our numerator, 3 minus root 3 over 3 times the reciprocal of the denominator. I'm flipping that denominator. And what's nice is that these 3's cancel, but you cannot cancel anything else because it's not multiplication. So we're going to end up with 3 minus root 3 all over 3 plus root 3. And we're not quite done because we do need to rationalize our denominator. To rationalize a denominator with addition or subtraction of a radical, you multiply by the conjugate. So we've got 3 minus root 3. This is the conjugate of the denominator. When we multiply in the numerator, we're going to have to FOIL. So we've got 3 times 3 minus 3 root 3 minus 3 root 3. And then the root 3 times itself, the square roots essentially cancel, leaving us with 3. In the denominator, multiplying those conjugates, it simplifies quite a bit more nicely. We get the 3 times 3. The negative 3 root 3 cancels with the positive 3 root 3. And then the root 3's together, again, those square roots kind of cancel each other out. And we're just left with the 3. Simplifying that mess in our numerator, we have 9 plus 3 is 12. And the two negative 3 root 3's combine to negative 6 root 3. And in the denominator, we've got 6. So we can divide everything by 6. I'm kind of doing the butterfly method here. 12 divided by 6 is 2. And 6 divided by 6, of course, is 1. So we have 2 minus root 3. We're going to take a look at one more, this time in radians. And I will try to do this a little bit more quickly since we've already seen an example. This time we need to recognize that 7 pi over 12 is pi over 3 plus pi over 4. So you've got to be really good with your fractions. These both have a common denominator of 12. So this is really 4 pi over 12 plus 3 pi over 12. So we're going to use similar formulas, except for this time we'll be adding all of them. So we're going to use all of our adding formulas. So that one for sine, this adding one for cosine, and this adding one for tangent. Starting with sine, we've got sine of pi over 3 plus pi over 4, which gives us sine of pi over 3 times cosine of pi over 4 plus cosine of pi over 3 times sine of pi over 4. This is, again, a nice one for sine and cosine because we've got that pi over 4 value, which is the same for sine and cosine, so we're going to have similar answers, and our cosine will go relatively quickly once we figure out our sine value. Sine of pi over 3, sine goes in order, 1, 2, 3, so at pi over 3, sine is square root of 3 over 2. Another nice thing about this one is we've got 2 first quadrant values, so everything will be positive. So cosine of pi over 4 is root 2 over 2. Cosine of pi over 3, cosine goes backwards, so cosine will be 1/2. Sine root 2 over 2. When we multiply these together, this is pretty similar to what we got on the last one. We have square root of 6 over 4 plus square root of 2 over 4, which gives us square root of 6 plus square root of 2 over 4. Now you can't add these together under one radical. It's quite tempting to say that's the square root of 8, but it doesn't work that way. So looking at cosine of pi over 3 plus pi over 4, we're going to have almost exactly the same answer except for subtraction. So we have cosine of pi over 3 times cosine of pi over 4 minus sine of pi over 3 times sine of pi over 4. Substituting the values we already figured out on the last one, cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2. This time we're subtracting. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. So we have root 2 over 4 minus root 6 over 4, which gives us square root of 2 minus square root of 6 all over 4. And finally, let's take a look at our tangent one. Again, tangent's very similar to the other one. We're just adding in the numerator and subtracting in the denominator instead. So we've got tangent of pi over 3 plus pi over 4, which gives us tangent of pi over 3 plus tangent of pi over 4 all over 1 minus, and multiplying them together, tangent of pi over 3 times tangent of pi over 4. What's really nice with the tangents of pi over 4 ones is it's 1, so they essentially cancel out when we multiply. In the numerator, tangent of pi over 3 is square root of 3. That's up at 60 degrees, plus 1, all over 1 minus square root of 3 times 1. So this one's quite a bit nicer than the last one in that we don't have that fraction within the fraction. So we get to just rationalize our denominator right away, multiply by that conjugate. In the numerator, when we FOIL, we get the square root of 3 plus 3, that's root 3 times root 3, plus 1 times 1, plus 1 times the square root of 3. In the denominator, multiplying our conjugates, we get 1 minus 3. So remember, the positive root 3 will cancel with the negative root 3, and the square roots cancel when we multiply them together as well. So for our final simplification on this one, in the numerator, I like to put my regular numbers first and my roots second. So I've got 4 plus 2 root 3 all over negative 2. Butterfly method again, 4 divided by negative 2. And of course, 2 divided by 2 gives us that negative 1. Due to how complicated and long some of these problems can get, I decided not to do a U-try on this one, and we can start the assignment together in class instead.